Hello friends, welcome. Let us learn how to write a dual of a transportation problem. In the previous lecture, we have already discussed about the linear programming problem of the same transportation problem. That was, say, primal. Now we are going to write its dual. We know the basic rules of primal, rather like writing dual. In primal, there were 3 into 4, 12 variables. So now in dual, there will be 12 constraints. Number of variables in primal equals to number of constraints in the dual. Similarly, in primal, we had 3 constraints related to supply and 4 constraints related to demand. So we had total 7 constraints. And what is the rule? Number of constraints in the primal equals to number of variables in the dual. Here we have 7 variables, 3 related to supply and 4 related to demand. Now let us write. We know that transportation problem is originally a minimization problem. So the dual of a minimization problem is always a maximization problem. But these are the dual variables. Now what is our objective? Maximize. What is to be maximized? Product of supply units and UI and product of demand units and VJ. So that will be 500 U1 plus 300 U2 plus 200 U3 plus 180 V1 plus 150 V2 plus 350 V3 plus 320 V4 subject to what? Now the constraints. What are the constraints? When we had discussed the optimal solution of a transportation problem, we had already used UI and VJ, and we know the relationship between these two. UI plus VJ equals to CIJ. That will be the format of our constraints. U1 plus V2 less than or equal to 12. Similarly, U1 plus V2, here it should be V1, U1 plus V2 less than or equal to 10, U1 plus V3 less than or equal to 12, U1 plus V4 less than or equal to 13. Similarly, now 4 will be for U2. U2 plus V1 less than or equal to 7. U2 plus V2 less than or equal to 11. U2 plus V3 less than or equal to 8. U2 plus V4 less than or equal to 14. Now for constraints for U3. U3 plus V1 less than or equal to 6. U3 plus V2 less than or equal to 16. U3 plus V3 less than or equal to 11. U3 plus V4 less than or equal to 7. This is a minimization case. Less than or equal to sign are relevant to minimization. Moreover, this is the shadow price. U and V are the shadow price of the, say, units, and which can never go beyond the cost per unit. It will be less than or equal to 12 for an optimal solution. Remember the calculation of Dij. if any Dij value is negative, the solution is not considered as optimal. So to have the solution considered as optimal, all Dij values should be 0 or negative. What is the formula of Dij? The formula of Dij is Cij minus Ui plus Vj. That means if Ui plus Vj is greater than Cij, the Dij value will be negative, and we conclude that it is not optimal solution. So to have a solution optimal, Vi plus Ui plus Vj must be equal to C or less than C. So the sign less than or equal to is there. Ui plus Vj less than or equal to Cij. Then only 0 or positive Dij is possible, and then only we can conclude that the solution obtained by us is an optimal solution. That's why the sign less than or equal to is there. Now, what about the negativity or non-negativity? As we know that u and v can take any type of value. 0, you are taking arbitrarily one value as 0. It can be positive or it can be negative. So we can say that ui and vj's are unrestricted in sign. u1, u2, u3, v1, v2, v3 and v4 are unrestricted in sign. So this is dual of a transportation problem. That's all. Thank you.